was called Rationalizing the Denominator. So on Wednesday, we looked at how to multiply radicals together, and today we're going to look at how to divide. So if I'm asking you to take the square root of 16 over 25. Okay, if there's a fraction inside or underneath the radical, then what we do is we break up the fraction and we say, well, that's just the square root of the numerator over the square root of the denominator. So I would take the square root of 16 and I would divide it by the square root of 25. Well, what's the square root of 16? 4. And what's the square root of 25? 5. And there's no radical left. It took care of itself. The answer is 4/5. And sometimes that will be the case. Okay, we've got 13 over 100. If I apply my same rationale here, and I take the square root of the numerator and I divide it by the square root of the denominator. Just set those right there. Thank you. What is the square root of 13? Do we know it?
It's a prime number.
It's a prime number. So it's not even going to simplify. There's nothing that I can bring out from underneath the radical. It's just going to stay the square root of 13 over, how about the square root of 100?
10.
That's 10. And it's okay to leave your answers like that. We do have a radical in the numerator. And that's okay. That's as far as we can simplify it. We just leave it like that. Might have variables involved also. 7 over x squared. So if I break that up and say, well, that's the square root of 7 over the square root of x squared, I would try and simplify the square root of 7, but 7's prime, so nothing comes out. So I'm just going to leave it like that. But how about the square root of x squared? That's just x. And again, we can leave our answers with a radical in the numerator. Now, if you break that up, and yes, you could reduce the fraction first if you wanted to. So I could say that that is the same as the square root of what? 1 over 5. So you are welcome to reduce the fraction before you break it apart. Okay, you'll get the same results, so that's okay to do that. But when I take the square root of 1 and I put it over the square root of 5.
Both prime numbers.
Okay, but what's the square root of 1?
1.
1. Okay, that does simplify into 1. There's no radical there. But can I simplify the square root of 5?
No.
No. And this is where we have a problem in math. We cannot leave a radical in the bottom of a fraction. Okay, we cannot do it. It's against the rules to do that. So what we have to do is the process that's called rationalizing the denominator. We call it rationalizing because as it sits, this value, square root of 5, is an irrational number. It's a decimal that doesn't repeat, doesn't have a pattern to it. It's irrational. We want to make it a rational number. So we have to get rid of the square root. You think about square roots. How many does it take to be able to bring out from underneath the radical? 2. And I only have 1 5. So what I'm going to do is I'm going to multiply it times itself so that there's now 2 5s underneath there. And if I do that to the bottom of the fraction, I have to do the exact same thing to the top of the fraction. So that rule for fractions has always been, and it still applies. Whatever you do to one piece of the fraction, in this case the denominator, we have to do the same thing to the numerator. And we multiply fractions straight across. So I would take 1 times the square root of 5. It's just the square root of 5. Over, from yesterday, what's the square root of 5 times the square root of 5? The square root of 25, which is going to simplify into what?
5.
It's just going to be a 5 with no radical. So the answer is the square root of 5 over 5.
So we're just technically removing the radical from the bottom and just putting it on the top?
No, because you're going to see some other examples where it doesn't work out like that. Okay, in this case, yes. But we cannot leave an answer with a radical, so we have to rationalize it. We keep going until there's no radical in the bottom. Some of them just start out that way. So I have 5 divided by the square root of 7. Okay? Can't simplify the square root of 7. It's prime, but I can't leave a radical in the bottom. So I have to take care of that. I'm going to multiply by itself. I'm going to take it times the square root of 7. That way there'll now be 2 of those 7s in the bottom. If I do that to the denominator, I have to do the same thing to the numerator. When you multiply straight across, 5 times the square root of 7. What's that product? Can I multiply the 5 and the 7 in this case? No, you cannot. Because this is not under the radical, and this is. So we just write it as 5 square root of 7. It's a product. We still can multiply it. We just don't multiply the 5 and the 7. Over, what's the square root of 7 times the square root of 7? Square root of 49, which equals 7. There's my answer in rationalized, with a rationalized denominator. No.
Would you be able to just cancel out the square roots and just use the number?
What do you mean to cancel out the square roots?
So you're multiplying the square roots by itself.
Yeah.
Would you be able to just get rid of the square
Skip
root
that
sign
and go to
just
that?
Skip that step?
Yeah. Yep. That's true. I'm going to show you that step today just because I want people to make that connection. Okay? Big yes. Okay, try this one. How about 3 over the square root of 2? Okay, can I simplify the square root of 2 at all? No, so I need to rationalize the denominator. So I'm going to take it times itself, square root of 2. If I do that to the bottom, I have to do the same thing to the top. So what do I have in my numerator if I multiply here? 3 square root of 2 over. We always put the number without the radical first, followed by the radical. So don't write square root of 2, 3. It's 3 square root of 2. And then the square root of 2 times the square root of 2. That's the square root of 4, which is going to simplify into 2. Now, would I be able to cancel these 2's?
No.
No, you cannot. This is under a radical. This is not. So you cannot cross out the 2's. And the reason for that is this value, square root of 2, is different. It's not the same value as 2. You did it on your calculator, it comes out to be a decimal, 1.41 something, something, something. So they're not the same. That's why you can't cancel them out. Okay, you leave your answer just like that. Okay, you might have something like the square root of 5 over 48. And again, if this ever divides or reduces, go ahead and reduce it before you do the square root. So it'd be the square root of 5 over the square root of 48. Now, does the square root of 48 simplify? It does. If you want to simplify now, you can. Or you could multiply by the square root of 48, top and bottom, and then you would just have to simplify. Eventually, it's going to reduce. You're going to get the same result. But if I want to simplify this now, I can. What are factors of 48? I heard mumbles. 12 and 4. And 12 is going to be 3 times 4 and 4. Now, stop here. I'm not going to go all the way down to all the 2's. I'm going to save myself a little bit of time because I have a pair of 4's. So even though they're not prime, because they're a pair, you can bring them out, and it's going to save you that step. Otherwise, you'd be taking 2 sets of 2 out. It's going to give you a 4 anyway. So I can say this is the square root of 5 over. The 4 is going to come out, and the 3 has to stay under. By simplifying it, you have smaller values that you get to work with. So there is some advantage to doing it now. Now, I need to get rid of the square root part. So what would I multiply by? Just the square root of 3 is all you have to multiply by. What's the square root of 5 times the square root of 3? Square root of 15. When I multiply these together, the 4 gets, there's nothing here, there's a 1 there. So it's 4 times 1, it's still a 4. And then I would take the square root of 3 times the square root of 3. It's the square root of 9, but what is the square root of 9? It's a 3. So that's 4 times 3, which is 12. So that answer is going to be the square root of 15 over 12. Variables work the same way. If I asked you to take 1 over the square root of x, can I simplify? Can I bring anything out from under the radical with the x? I don't have enough, right?
No.
So I would have to multiply by the square root of x.
In this case, you still get
So 1 times the square root of x is just the square root of x. Square root of x times the square root of x. Square root of x squared, which is
just x over.
x. Just x. So you get the square root of x over x. Can I cancel these x's out?
No.
No. When a number's under a radical and a number is not, you cannot reduce them. Okay, now this is not easy stuff. Algebra 2 kids struggle with this too. So give yourself a break. Try it. Wrestle through it.